So we are being asked that a body of mass 25 kg moves with this, that is 2 meters per second on a rough horizontal floor, is brought to rest after sliding through a distance of 2.5 meters on the floor. Calculate the coefficient of friction, and they gave us the acceleration due to gravity. So how do we solve this question? So we'll go straight to the solution. So what the first thing to do, as we have always been doing, is to draw the force diagram, because force diagram is going to help us to understand the question very well. Now look at this force diagram. Now this is the mass of the body, this is the normal reaction, and this is the weight. Now we have the frictional force here acting backward. Now remember, they asked us to find the coefficient of what? The sliding friction. So this question is a question of dynamic friction, because if you remember, we said that we have two types of friction. We have the static and the dynamic friction. So dynamic friction is the friction of a body that is already moving. So this body was moving with 3 meters per second, and it moved to a distance of 2.5 meters, and it came to a rest. So what are the parameters we have here? The parameters we have here is that we have the mass of the body 25 kg, we have the initial velocity as 3 meters per second, the final velocity as 0 meters per second, acceleration due to gravity as 10, distance 2.5. So they ask us to find the word mu. So from the second law of motion, we have that this v square is equals to u square plus 2as. So it means that what, making a the subject of formula, this is going to be v square minus u square over 2s. So we are now going to impute the value. So it means that a is equals to 0 square minus 3 square over 2 times 2.5. So our a is going to give us minus 1.8. So minus indicate that this is actually what the body is actually decelerating. So what we are now going to do is that recall that force is equals to mass times acceleration. Now by the time you have done that, now it means that and also you should remember that friction is equals to mu r, and r is what? Mg for an horizontal body. So it means that our net force for the sliding, ma, is equals to mu mg. Now making mu the subject of formula, it means that what? Mu is going to be equals to what? Ma over mg, and the masses we cancel out. So it means that what? Mu is equals to a over g. So applying this, our a, the acceleration we got was 1.8, so divided by 10. So the coefficient of traction is going to be what? 0.18. And remember, coefficient of friction have no what? Unit.